My name is Jeff Schertz. I'm the lead Microsoft solutions architect for Polycom, and also excuse me, Lync MVP since like the OCS days. So that's enough about me. Let's get to the content. So I'm gonna kind of cut this up in like 4 sections. We're gonna hit like 300 level content, but I'm gonna walk through it. I'll make sure everyone in the room, based on whether you know video really well, intimately, and you want to know some kind of nerdy technical details, or maybe you've used Lync and you're not quite sure what's actually happened under the hood. So I want to kind of walk through that story, make sure that when I get to the last piece, that everybody kind of understands how we got there. And when we get to some of the numbers, they make a little bit of sense. But feel free to ask questions at the end. You'll have to come up to the mic. I'm sure you know by now the routine, so we get everything recorded. But go ahead and save them for the end. For some reason, these sessions are 15 minutes longer than the ones we did earlier. So I'm probably going to hopefully speak a little bit slower and more articulately. And maybe hang out on a couple slides that I want to kind of put a little bit more content in, but we'll have plenty of time for Q&A at the end, and then even afterwards, feel free to come up and ask me any questions. So the approach here is that I kind of want to go through some of the foundational concepts, like I said, make sure everybody understands where we're going, take a look at the video experience, what you see as a user, what you can manipulate in Lync. You know, Lync's very unique in that traditionally video, a lot of times you just get what you get. You can't really mess with stuff. Maybe you can change the screen size or things like that, but there's a lot of new capabilities that were brought into Lync 2013 that, as a user, give you the ability to manipulate your screen. And what you're actually doing is manipulating bandwidth requests. So you could do something in your presentation or in your conference call, or even a peer-to-peer call, that might impact what another person or other persons are receiving or sending and encoding and decoding. So we'll go through that story. Then we'll take a look at the actual numbers and compare streams, compare different types of use cases, and then we'll actually go and take all that we've learned and look at some information that Microsoft was nice enough to share with me for this deck. And what we're going to do is look at actual data from Microsoft's own video usage from the whole calendar year of 2013 that comes from their monitoring database. So there's some interesting takeaways from that. Keep in mind that Microsoft has a unique corporate culture in terms of how video is used, but it's not so unique that other companies may not have the same thing. But just realize that this is one example. So there's parallels we can take away in terms of how it compares to some and others, but generally the story, hopefully you'll understand. And really the key for this is for me to have you guys walk away and just not be afraid of video. I know when Lync 2013 came out and a couple marketing slides came out and everyone's like, oh my lord, there's going to be 5 streams of 1080p data, and the network guys were like running to CDW to buy switches. It's not like that at all. What you'll learn is it can scale in bursts up to certain amounts, but you're going to find out that the planning is actually planning for low averages. So you want to leave yourself some overhead, but it's not scary at all. It'll probably look like that as we go through the story. You'll see some numbers that make you scratch your head, but by the end I want everyone to kind of understand that and take away that if you're not using video in your deployments today, or maybe you're limiting it, maybe you don't need to. I'm not saying that. Just go ahead and let it run loose and see what happens to your network, but maybe you don't have to, ring it back so much. So this is interesting because when Microsoft reviewed the deck, they're like, why are you starting with RTV? One of the things I found in the field is a lot of people think RTV is like not available or not applicable. Certainly you can do Lync 2010 calls with 2013. Lync 2010 clients can join. Microsoft did a really good job of not forcing you in more recent versions of Lync of saying you have to do server or client first. So there's scenarios where if you're doing these migration waves, RTV is still applicable. It's still used, but only when a legacy system or legacy Lync client comes into play. There's a couple unique enhancements into RTV. Realistically, it's just used for when 2010 clients come into these stories. But some additional resolutions were added. One of the things that was really limiting about RTV is there was only one resolution that was widescreen. And that was 720p, and you needed a quad core, and the weather had to be perfect, and then you might get that high definition. So what you see with 2010 clients joining these environments is that everything's widescreen now in terms of cameras. I mean, back when our TV was designed, HD camera was something you had to go buy and plug in the computer. I mean, my cell phone has 2 widescreen cameras on either side of it at this point. So the ubiquity of these high-definition lenses to capture the information is out there. So now when you're doing Lync 2010, you're going to get a better image in terms of actually capturing what you should see. And we may crop that later, and we'll talk about that in a few slides. But realistically, the rest of it's the same. So when a 2010 client comes into a call on the AVMCU, the conferencing server in Lync, it's still limited to what it was before in terms of its high definition, or its VGA. It's not high definition. So SVC or H.264 SVC is what provides that. The features that were added to the product for this have been out and known for quite a while, so I'm not going to go into all of them, but there's a few that are kind of important to how we're going to build out the story here. So one of the things is that hardware acceleration is utilized to encode and decode higher resolutions that previously were not applicable or not available in RTV. So given the same piece of hardware, the same camera, the same processor, the same graphical processing unit, when I upgrade to Lync 2013, I might now be able to encode in 720p when I wasn't able to before, or I may be able to decode 1080p when I was not able to before. So one of the benefits is making high-definition video more common without actually having to swap out hardware or add pieces. One of the things that's cool about it is if you have Windows 8 and there's some new cameras out there that support this USB video class offloading of encoding, what Microsoft does is basically the processor can do a lot of the encoding, but if the graphical processing unit in the PC is compatible and the embedded Intel chipsets, like all the Core i5s, i7s that use the Intel HD graphics array, those all support that. So the PC at the time that the request comes in can say, hey, there's nothing going on in the GPU. Let me use that to do all the media encoding. So what I have here is an example of the same Lenovo laptop with one with a Microsoft Live camera that doesn't support that. And it's run about 60% CPU to do like a peer-to-peer 720p call. Take that camera off, plug in a Logitech camera that does support that. Same exact call, same person, same network. I mean, this is moments later. That same call is now only utilizing 30% of the CPU. So now one of the benefits there is that when I get in a video call and I go full screen, I can actually still use Outlook. I mean, I can use the rest of the applications on my computer, and my fan doesn't go up to 100,000 miles an hour. So the real-world capability there that allows you to encode and decode depending on what that hardware is. So what that does is make higher definition resolutions more possible. Doesn't mean it's always going to be utilized, but they're going to be more common. So one of the other things that's important to understand with H.264 is the scalable video coding component. So the actual specification for the codec that Lync uses has many, many pages of data. It doesn't mean that's exactly what Lync is doing. So Lync was implemented to kind of take the first couple steps. So this codec is flexible, and in future versions, Microsoft could continue to move up the scale. As with anything, it's not free. So as you move from mode 0 to mode 1, I'll explain what those modes are, but the higher you go, the more capabilities you get. You can do things like saving bandwidth, but there's a cost involved in that, and the cost is typically on the encoding endpoint. So I might use more processing power, but I might save bandwidth over the network. So based on where everything is in the industry, it's safe to take those first couple steps and get that benefit, but as computers get faster and processing gets cheaper, then this codec has the ability to scale, so it's not going to be like in the next version of Lync, we're going to go to H.265 or something, because it's not, this is for the long haul in terms of the usage of this codec. So mode 0 is just basically nothing. It's just default, flat, no bells or whistles. Mode 1 is what's called temporal scaling, and what it does is it allows you to mix frame rates in the same streams. So in the next couple of slides, I'll go through what that actually looks like. But Lync does do that. So when you have these multi-party calls with a lot of different mobile phones, Lync room system, different capabilities, they're going to ask for different frame rates for different reasons. There could be limitations on bandwidth, could be limitations on the connection, the USB 2 versus USB 3, there's different throughputs there. So there's reasons that an encoder or a decoder might say, hey, send me video and this is what I would like to get. And what we don't want to do is send a single unique request for every different one and tax that encoder so that it's doing too much work and sending too much over the network. So mode 2 and up. So mode 2 is called spatial, and then mode 3 is a combination of those. So as you move up, you can say, I'm going to do a little bit of this and then a little bit of that, and then say, well, I'll do more of this or all of it. So as you go higher, or in this graph, lower down the flow chart, there's a cost involved there. So what Lync 2013 does is it utilizes mode 1, temporal, but it does not utilize spatial. So I'll compare and contrast those two in the next couple slides, and you can see what it's doing today in terms of benefit and what it isn't doing yet, but what it can do, and then also why that's not really, it isn't important that the fact that it's not going to mode 2. we're losing out on saving a ton of bandwidth. Another thing is that in previous versions, real-time video, you had active speaker everywhere. If there's a round table, you might have a second video session, and I'll break that out later. But the idea is you're encoding a single stream, and you're sending it, and then you're receiving a single stream and decoding it. But when you look at the gallery view in Lync, there's multiple streams there. So Lync not only has 2013, not only has the capability to support multiple streams inbound, it has the capability to support encoding and sending multiple streams outbound. Now, there's not multiple streams like I have to encode a separate stream for every person that joins the call, but there's in that mixture of requests of different different mixtures of frame rates and qualities and resolutions, it might be ideal for me to send a couple examples. So if everybody in this room got on a call and I sent one resolution, everybody would get that. But if everyone has different requests, maybe I send 3 and everyone picks the one that's closest to their request, but I'm not sending 50 streams because that would be ridiculous. So to look at how temporal works, and this isn't, these next couple slides are not an exact representation of how Lync actually works. It's a little bit deeper than that. And I guess quick show of hands, did anybody sit in the 400 level video deep dive session yesterday? Oh, wow, okay, cool. So there's a lot of overlap in some of these sessions, so that's good. So then you won't fall asleep halfway in here. One of the things they did in the 400 level part, this is 300 level, so I won't get quite to that, but they went into how the layers are stacked. And the way Lync works is right now it's sending 2 layers, layer like 0 and 1, and they can send 2 sets of frames, and they're kind of additive. So I'll talk more about that in a second. But the idea here is it doesn't mean I send 1 and 3 or 4 come out. So I'll go through that. So the example here is there's a single, like I'm client 1, I connect to a conference call, I do a meet now, or I get dragged in, or click on Lync meeting. Another client joins, and they're requesting my video. And pay no attention to the fact that there's like 3 heads in there, because right now it's just 2 people on the call. Or maybe there's other ones, but they're all the same. So it's really what we're talking about is what these lines are representing. So it requests for resolution, don't worry about, requesting 15 frames a second. So my client will encode at 15 frames a second and send that. So now let's say another client comes in for whatever reason it wants a lower frame rate. With utilizing the temporal abilities, I'm not required to start over and send a whole other stream that caters to that request. Because they're asking for the same resolution but at a lower frame rate, that information is able to be extrapolated from what I'm already sending. So basically, one of the layers is stripped away by the MCU, and there's no additional processing cost on my endpoint. So I don't have to encode additional, do the video again, send another stream of bandwidth or anything. I'm just sending the highest requested, and the MCU is basically a traffic cop. It's saying, all right, send both of these streams together here to get to 15, and then drop one of those streams, and it's cut in half. It's important to note from a bandwidth standpoint, it's not actually cut in half. So in this scenario, it's not half of the bandwidth. It's more like around 20 to 40%. It varies because there's a lot more data in packaging the stream. It's not literally just dropping every other frame. It's dropping parts of the data. So on the inverse, say someone comes and joins the call and they're requesting a higher resolution or a higher frame rate. Now, like I said before, it doesn't mean it's going to happen. My client computer, my Lync 2013 client on client 1, I kind of have the end say-so in terms of what actually is going to happen. I'm not just going to be like, all right, here's another one, go, and I'm on Starbucks Wi-Fi, and this is going to be terrible. It's going to say, look, this is how much bandwidth I might have. My processor's a little bit spiked. I know you want 30 frames a second, but 15 is all you're going to get, and I'm already sending it. Don't worry about it. But in this scenario, we don't have that limitation. So what's happening is that 30 frames, I can send it, but now my client has to kind of kick up the amount of data. So now I'm encoding more data, but it's still embedded in the same stream. So again, I can send a single stream and provide multiple frame rate requests. So now this is conceptual on how temporal works. The way it actually works in Lync is in this scenario, I would actually have to send 2 streams. Because Lync can send 2 layers, so layer 0 and layer 1. I'll just dive into 400 for a few minutes. Those layers, like one example would be sending 2 layers of 7.5 frames. So one session goes out, and layer 0 is 7.5, and layer 1 is 7.5. The MCU is going to just send one of those layers to the little guy. It's going to send both of those layers to client 3, so that it's 7.5 times 2. And then when the third PC comes into the call, and I have to do 30, what's actually going to happen is the Lync 2013 client is going to encode a second stream of 2 streams of 15. So basically, I have to give 7.5 times 2 and 15 times 2, and from that, I can cover all 3 of the frame rates. So if there were like 10 frame rates capable as being decoded in the Lync implementation, I couldn't send 10 frame rates in one. So it scales to a point, but the biggest benefit is that what you typically see in Lync is 30 and 15 frame requests. 7.5 is possible, but it's rare. It would happen on very constrained networks, but typically the resolution might go down in those scenarios. Or honestly, if you can't do 7.5 frames, you probably shouldn't be doing video at that point. It's not going to look that great, and who knows what's happened to the audio. So, so the benefit there is that multiple frame rate requests and not a hit on the network in terms of the amount of bandwidth that has to be amped up for that. So if we take a look at spatial, which this is, again, conceptual for how spatial works, but Lync does not do this, so I'll show what Lync actually does without the spatial capabilities. Same example as before, but now we're looking at resolution instead of frame rate. So forget frame rate. Client's asking for 360p. I'm going to go ahead and send that. Client comes in asking for less resolution. Unlike temporal, or unlike what we did with the ability to use temporal, since we don't have spatial, we have to encode another client or another stream. So if mode 2 spatial was supported, it would look just like the temporal. It would be like, hey, I can do 180p and 360p in the same stream. In layers, it would be 180 in a layer and 360 in a layer. And then I can send one layer to the low requester and then both layers to the higher requester. But since that's not in the Lync implementation, what you'll see is that it's a whole other stream. So I'm grabbing the video again, I'm encoding it again, I'm packaging it again, I'm sending it in the network. And there's no savings in any of that yet in those two streams. So it's A plus B plus literally C. So for every request I send out, it's that whole thing. So it's a 720p stream plus a 360 plus a 180. There could be up to 5 streams sent out. You're almost never going to see that. Lync's not just going to say, hey, send out 5 streams, because a lot of times it's going to say, I'm already doing 2 or 3. Go ahead and take which one of those you like. And we're also going to find out later in the session that these types of scenarios don't happen all that often. You can trigger it, but the typical usage of Lync, just because it's built into there, doesn't mean that every video call you have is just going to start using every capability. So to dive into those stream capabilities a little bit more, when you're an encoder, there's actually 2 video sources that are defined. There's the main video source, which is your camera, USB camera, whatever you plug in. The panoramic, the old Microsoft Roundtable, the Polycom CX device that provides that panorama view, that's treated as a whole other video source. So if you have Lync connected to a panoramic camera, even though it's one set of camera lenses, it's actually 2 sources. So the primary view, or what would normally be captured and sent in a standard built-in video camera or a USB camera, that information is pulled from the panoramic slice in a full resolution, and then the panoramic is stitched across all 5 cameras in a smaller resolution, and they're both sent as separate streams. So we'll see later in the numbers that those are calculated separately as well. So in theory, if you had every possible combination and you were on a network with infinite bandwidth and 0 packet loss and everything was perfect, you could actually encode, and you had enough requests. You had 100 people all at different screen sizes. You would have the ability to actually encode 5 streams. And in those streams, those could be a mixture of resolutions, or going back to the temporal example, it could be a mixture of frame rates, because maybe I need to do 7.5 and 15 together, and then the 15 and 30 in another complete session. And again, I keep harping on this, but I don't want to scare people. When we get to the slides at the end, you're going to see the actual utilization is nowhere near the scale. But the key is that the scale can be there. So as in the future, as processing and bandwidth requirements decrease, then the experience can be better, basically. You can get more pieces to different people that's closer to what they're asking for. And I kind of talked about it before, but me as the encoder, when I have a video source request that says, hey, this is what I would like you to send, I'm going to look at what I have in terms of available hardware, like CPU, graphics, available bandwidth, what I'm already sending, if it makes sense to add more to the story or not do that. So again, I have that final say on whether it's actually going to happen. I as the Lync client. So if we kind of mix the examples together, what this is showing is like, hey, there's different requests from different clients, and the endpoint doesn't necessarily have to send all of them. So in this basic example, we've got 4 clients requesting, but I'm not sending 4 streams that are perfect for all of them. In this example, I'm actually sending the resolutions that we requested, but for the 2 center clients, they're requesting the same resolution with different frame rates, so maybe we'll use temporal from that same stream. In the example that maybe the client doesn't have the ability to do this, the guy that comes in and asks for 720, my client's going to say, sorry, you're going to just take 360. And then that bottom purple line would be gone. It would just be another piece of the green. So what you're going to see in large meetings is I might send 1 or 2 streams. Those 2 streams are pushed out to 50 to 75 or however many video clients that are on that call. So if we take a look at what kind of a mixed meeting would look like, I've got an example of each of the individual clients, not all the clients, but the major ones, right? So Lync 2013 client, the web application, the legacy Lync 2010 client, the 2013 mobile application, the modern UI application, another Lync 2013 client in there. So based on the client capabilities, what codecs they support, what version, there's different maximums in terms of, and these aren't even maximums, this is a specific call example. There's different amounts of streams that they're sending and receiving. So here what we've got is the active speakers on the Lync 2013 client. There's 2 things in this. One, because there's a Lync 2010 client involved, we have to utilize RTV. Because if I join from a down-level client to a Lync call, what we don't want to have happen is this least common denominator story where I come in and ruin it for everybody. And everybody's resolution goes into the toilet. Lync 2010 and OCS, based on RTV, would do that. So if you're on a call where VGA's in place and someone comes in, they can only utilize CIF. There's no transcoding. There's no multiple streams. So for people to see my CIF stream, that's what everyone's going to get. There's no upscaling or anything like that. So 2013 avoids that by saying, okay, when a Lync 2010 client comes in, we're going to add RTV to the mix on the fly. So let's say I'm the active speaker on the modern app. I'm going to encode an SVC stream, and you can see the orange lines going up. The solid line is SVC. The dashed is real-time video. I'm going to code an SVC stream that the AVMC is going to send to all the 2013 clients because I don't want to water down their experience. And they're not going to lose the gallery or anything. The key to understand here in these mixed mode scenarios is 2010 client, still a 2010 client, still sends and receives active speaker. 2013 client still supports gallery. So their native user experience and their version is not changed in any way. So what happens here in that call is I, as the active speaker, need to encode an additional RTV stream because the guy in the Lync 2010 client needs to see me. So I'll encode an RTV stream, but what it doesn't mean is that everyone in the call all of a sudden starts utilizing RTV. Because the key is it's active speakers, so there's only one person that can show up on an RTV client, so there's only the need to encode the active speaker. So you'll see there's no RTV going out of all the other PCs. They're only sending SVC for the ones that aren't the active speaker. But they're receiving RTV, because one of the key things to understand is the SVC codec is not necessarily what provides the multiple views. So I talk about multiple streams, about providing different amounts of data, but the multiple views is like 5 users in the gallery. Those can be a mixture of SVC and RTV. So in this call, if I look at the gallery on the Lync 2013 client, 4 of those heads are SVC, and 1 of them is RTV, because I still see the Lync 2010 client. So they see me, I see them. When the active speaker switches, whoever becomes the active speaker has to add that, encode that secondary RTV stream, and then who was the active speaker last actually stops sending that. Technically, it can be a little bit more complicated than that, because if there's multiple 2010 clients, and if you've ever done it, video conferencing in the past, if you're the active speaker, you see who the last active speaker was. When a new active speaker comes in, everyone sees that, but you still see the last person, because you never see yourself. At least you shouldn't see yourself. It used to happen in some scenarios, but you never want to see yourself, because it's kind of, it's not a good experience from a video standpoint. You get distracted. You're like, I don't look too good. So different client capabilities. If we have the panoramic into this scenario, now we have that same requirement to send additional streams. But again, the 2010 client does support that panorama view. So I got to encode an RTV session for him, but I don't want to send the low-resolution RTV session to all the 2013 clients, because maybe I have a new CX device that has high-definition capabilities for the roundtable or for the panorama. So what happens there is that I'm sending an SVC stream at maybe a middle to high resolution, and I'm sending that one RTV low-resolution stream out. So what we're seeing here is the Lync mobile client is just cruising along like, hey, I'm on the Starbucks Wi-Fi or whatever, and this is working fine. I've seen different people, no big deal. The 2013 client to the 4 o'clock position, there's a lot of stuff going on there, sending a lot of streams, and it could even be more than that, because I'm just showing individual people. Some of those could actually be the 2 streams for temporal or 3 streams for resolution. So the scale can get big. The other thing to understand is I take a picture of this, and 5 minutes later, it looks nothing like this, assuming that people are joining the call, ending the call, different screen sizes, which the next section I'll go through. So keep in mind this is very dynamic, and you can't just go, well, here's what our conference looks like, and we have this many users and this many clients, and that means this much bandwidth, and this is what I'm going to plan for, and it's going to always be that way. Because you'll be right for about the first 2 seconds of the call, and then everything just goes crazy. And then what you'll see at the end is it doesn't go crazy. It actually stays pretty consistent. So, yeah, you'll see at the end. There's a lot of things that can happen here, but you'll actually see what in practice and in reality does happen. So if we take a look at the client video from the 2013 experience, there's multiple ways that you can see video. Gallery, which can be 4 to 5 users depending on the client version. Active speaker is still in there, just called speaker view. There's scenarios where that would be applicable. One, I just want to see that person bigger, and I switch to speaker view. And when I do that, what we looked at in the slide before, things happen. I ask for higher resolutions because I'm looking at myself in large, but other people will be looking at me in a small screen yet still. So now there's different requests for video. A unique capability in Lync in 2013 is the video spotlight. And what you'll notice is when I'm in speaker view, it's still cropped. And we'll get into the cropping and framing in the next couple slides. But that's just the default behavior of Lync. When you do video spotlight, it kind of mimics a peer-to-peer call where widescreen, so either 4:3 or 16:9, depending on what the encoding information is. That's shown there. What's cool about video spotlight, and this really underscores how smart Lync is about video, if no one can see me, my video is not being encoded and sent. There's no point. The AVMCU is smart enough to say, hey, this person's video is being requested by no one because the client is either switched to speaker view and they're part of the gallery, they're not the active speaker, or they switched to compact view, or they've turned camera off. But at this point, no one's requesting to see Jeff, so I'll tell Jeff to stop sending video. I'm not going to waste processing and bandwidth sending something. And this stuff happens dynamically so quickly on the back end that the minute someone alt-tabs and brings their video screen back, the video will get re-requested. So if you're ever in meetings, you see people joining or you see people changing stuff, what you'll notice is the Lync contact photo, either the embedded or the high-resolution photo from Exchange, will show up for like a couple seconds. Or if they don't have a photo, you just get that blue shadow person. Yeah, I've never heard anyone call it Smurf. Yeah, the blue Smurf. So they'll show up for like a split second because what's happening is on the back end, it's like, I know the video's not running, but go ahead and kick it up again. It's not like a whole media renegotiation process that could take a few seconds. It's, that channel's open. It's just like, it's like a mute basically. It's like, you're on video mute, session's open, but don't send any data. Okay, now please send data, and here's what I would like you to send, the resolution, the frame rate, aspect ratio, all that stuff. So we talked about this in that previous slide that had all the arrows going in 37 different directions. The different clients have different limitations in terms of how many they can show. The main thing is the 2013 Windows client and the web app will show the full gallery of 5. The Windows Modern application is limited to 4, but I was actually told the other day that there's a new version. I don't know if it's the next version, but Microsoft's going to update the mobile application to actually support the 5 as well. So it'll be consistent where it'll be the gallery equals 5, regardless of which Lync application it's part of. And then when you do active speaker, it's clearly 1. And the mobile application, there's no gallery. So there's a single low resolution of active speaker because mobile application is typically not on a high bandwidth connection, and sending multiple streams, 1, is complicated in terms of allowing that to happen, and 2, on a small screen, you're going to literally be looking at like little, people's faces aren't any bigger than the presence icon, so it doesn't add a lot of value. So smart framing and cropping are the next 2 subjects, and I kind of want to talk about them kind of intermixed. So SVC support, well, Lync 2013 basically crops video by default when you're in a conference call. The reason for that is to save real estate, and we're going to get into more detail on why that's important. But the idea is that Lync is primarily a desktop, and until we talk about where Lync Room Systems are bringing it, but from a historical standpoint, it's a desktop video solution. It's usually a person sitting in front of a computer. We don't care about my bookshelf over my shoulder or if my cat's sitting there on the radiator. It doesn't matter. We don't need that data. And by chopping the stuff down to a square, we're able to fit the 5 people in the gallery at a taller, a larger height, so higher resolution looks better. The more widescreens you get in there, the more it pinches down and everything is just smaller. Good for bandwidth, but maybe too small to add a lot of value, and I got to start messing with stuff, or I increase the gallery and I lose content. We're always fighting for real estate. So the cropping is applicable to both RTV and SVC sessions. So if I'm on a 2010 client, I still get cropped, but it's not smart cropping or framing. It's just straight down the middle. So if I'm on Lync and I'm using 2010, which I should know better anyway, I shouldn't be like hanging out way over here off the edge because it's not going to center me. The way that SVC works in Lync 2013 is it's actually going to locate my face, and if I move side to side, it's going to keep me framed. And my camera is obviously not moving on my end because the entire image of what the camera can capture is always being sent. But Lync is finding my face and sending coordinates in the RTC or in the RTP stream to the other client, the other Lync client, saying, "Hey, I don't know if you're going to crop depending on what you're doing, but if you are going to crop, here's where you should crop so that person's face doesn't vanish." So there's scenarios where the smart framing will not crop. One of the scenarios is just manually turn it off. The Lync client, you can turn it off, and that means it won't send any framing data. Or the framing data it sends will say, "Show the whole thing," and then you do that, and when other people see you in the gallery, your widescreen is squared off. So there's scenarios where maybe if you put a Lync client in a room, you might want to have that happen. There's other scenarios where Lync room system, as an example, will enforce that, because anything that's room-based, we want that widescreen. And the smart framing component of that is Lync will also notice when there's multiple people in the room. And notice I say people, because first my wife didn't want to be in the picture, and second I tried with my cat and it just did not work. So I took a photo of myself, put it up next to me in about 5 seconds, even less than that, and you see it on your own client in your active view. You see it pop out. Put my camera down, in about 10, 15 seconds, it drops. So it doesn't go crazy. So if you're in a scenario where people are walking past you, it's not making big changes. It's very similar to active speaker, where someone talks for a second, won't focus on them, but if they start to speak for a sentence or two, it'll go, okay, that's clearly the new speaker. Let me change focus to him. So the cropping component is basically taking that data for the smart framing, either just dumb framing, RTV, or no framing, or facial not identification, but location, sending that smart data. The Lync client decides if it will crop that. Like I said earlier, by default, it'll crop in a lot of multi-party scenarios. It won't crop in peer-to-peer. But what's important is that all the cropping means is the data is not shown on the receiving end screen. So there is no square resolution. We're not renegotiating a different resolution. So it's either 4:3 or 16:9, or invert those if it's a portrait view from like a mobile or a tablet device. We're always encoding the full array of what the camera can see. We're sending all that data over the network. The far end is decoding it. And when we get to the last step of just slapping it up on the screen, Lync's going to just say, you know what, don't show that. I'm going to squish some stuff and overlap that. So in this example, I'm kind of showing that this exact same call, when I switch between just the active speaker and the video spotlight, which is one of the ways to trigger full screen, that the video bandwidth is identical. And how I was able to get the exact kilobit in my screenshot on Task Manager, I'm not sure, because I know I didn't Photoshop this. That's a good, it shows that those are going to hover around that same. When I switch between it, you don't see the amount of data that I'm receiving on my client shrink by, a few kilobits. So I mentioned before, real estate's really important. And, this is Lync, right? It's not a video conferencing solution. It's a collaborative solution. So we're talking about a lot of components. But to kind of build the story, let's start with just video and maximize stuff. So we got 1080 or 1920 by 1080 screens. We're not going to get into like 2K, 4K scenarios, but keep in mind that math is applicable. So in the future, these numbers can increase as we're able to squish higher resolutions on smaller screens and then request multiple higher resolutions. But today what you're going to see is this is really the highest screen you're going to see on endpoints. A single call, and again, this is an example of real estate usage on like a conference call. I've hidden all of the ancillary menus in Lync. I've gone full screen maximum. I'm on that 1080p monitor. I can receive 1080p. The other end's got to have the quad core and all that stuff for it to really be applicable in most cases, but I can request that. So you can see how much of the screen I'm actually using for video, because it's all about painting those pixels. So every pixel that's got video on it is data that needs to be encrypted and sent over, or encoded and encrypted and sent over the network. When I get into a fully built-out gallery, I mentioned before, and these are squares, right? So if some of these happen to be widescreen, the height of that shrinks even more. But when you compare these, look how much less of the screen I'm using for video and gallery. So this is the start of what you want to understand, that a peer-to-peer call does not use less bandwidth than a gallery call. In most of the scenarios, conferencing is going to use less video bandwidth, and some of the numbers are actually very eye-opening. So So I mentioned before, let's look at a real case, right? So this is where I've got content, I've got the attendee list. Every time I put one of these things on a single screen, the gallery just keeps getting shrunk smaller and smaller. I mean, that's video. That's active video in those 5 streams. That's like a 180p request for each of those. I mean, the bandwidth on that is like a couple hundred kilobits. It's way below what you would see in an active speaker Lync 2010 experience. Now, clearly, the video is not adding a ton of value right here, but if I have a secondary screen, I can pull that gallery over to the screen, maximize it, and get more, or I could switch to active speaker. I don't need to see the other 4 people staring off into space. I just want to look at who's actually presenting. I could use Video Spotlight if I'm one of the presenters, so it doesn't have to be me. I can put the Video Spotlight on whoever's speaking, or if someone's asleep in the call, I can put it on them, and now he's 1080p on everyone's screen, and they can start IMing them to wake up during the call. There's different scenarios where you're going to change these screen sizes. So in this example, we're talking about very low usage of actual video bandwidth. The content's RDP, so it's a little bursty. You get a new slide, meg. The slide sits there. The content, it's not continual. It's not real-time communications. So one of the things that's important to understand here is that the more people you add to the call, the less room you have for actual video. It's just a matter of dimensions, it's geometry. So once we get to a fully built-out gallery call of 5, so 6 participants because you're in there yourself, and if you hide your local preview, you get that little wedge of space back, so you can start to get, the squares might grow a little bit, but it may not be enough to trigger like a new resolution request. Because as you change the size of all this stuff, your client's like, hey, I have more room for this video now, I'm going to ask that encoder for the next resolution up. Might not get it. So the other thing that happens is in these calls, all those resolutions may not be the same. For whatever reason, I could get 5 different resolutions for those 5 squares in there. I mean, typically it's not. It's a mixture of like the 2 adjacent ones in the list. But again, video conferencing in this scenario is not additive. It's not like, whoa, I've got 5 high definition video streams, and how am I going to handle 40 megabit? Another thing that's important, I've talked about this, that painting the pixels. The resolution, the pixel depth is what's important. It has nothing to do with the size of the screen. So I look at a 80-some-odd inch perceptive pixel monitor or a 5-inch Nokia phone. Both of those models are 1080p. So it's not like one is going to be 12 megabits of data and the other one's going to be 4 meg. I can send the exact same resolution to both devices. Now, would you want to do that? Maybe you don't want to do that, but that's where the capability comes from. Like, how much room do I have to show video at this given time? Here's what I'm going to request. And the size of the screen really has nothing to do with it. Now, if you're talking about a 2K or 4K monitor, it's not the size of the monitor, it's the resolution. So that's applicable, but if you had a 4K phone, the math would be the same. So I mentioned earlier, if you have multiple monitors, you can kind of increase the requesting, the amount of information you request. One of the unique things is with Lync, like I use dual monitors at home all the time, and I've got a camera over one, so whenever I do video calls, I drag video to the other side and I leave content on the one. It helps with eye gaze and also allows me to utilize a lot of screen space. With Lync, when you maximize video, it's going to pick whatever monitor that window's on and go full screen. It's not going to span across multiple monitors. You can do it. You can grab the window and like literally drag it over there, but you'll cut someone's head in half, and it's a weird experience. It's not really designed for that. Lync Room System has that built in. So if you're on a call with Lync Room System and you have the 2 screens and you're not doing any whiteboarding or showing any content, you might as well utilize the other screen that's just sitting there black. So there's an option you can tap on the screen, and what will happen is it'll move video to 2 screens. In that scenario, LRS has the ability to request more data. But in the other scenario where you're just doing, I have Lync on my 2 22-inch Samsung monitors, and I have gallery on one screen, and I go over to LRS with 80-inch monitors, and I have gallery on one screen, bandwidth is identical. But with LRS, if I kick it out to 2 screens, those squares get bigger, and the bandwidth may not change because all those requests may be denied. I may already be at the highest resolution that the client can send, each of those individual clients, or one might get better. So you'll notice individual resolutions where someone's on a poor network or something with poor optics. You can tell that one's different. Another one might look really good. So I talked a bunch about the panoramic, or the panorama video. What's unique about that is there's space carved out in the Lync client for it. So as you're changing views, adding content, removing it, adding people to the gallery, when you go from 2 to 3 to 4 to 5 and the video shrinks for that, panoramic is always based on the width of your window. So the panoramic's not going to change, but if I change the window size, I might be asking for higher or lower resolutions. But the panorama, there's just 3 resolutions in it, so there's not a lot of change. It's going to just typically be 1. What you may see is frame rate change instead of resolution, depending on bandwidth limitations or what have you. Another thing that's different is Lync. The video preview is a mirror. In traditional video conferencing systems, when you look at your video preview, you raise your right hand, it looks like your left hand's on, so it always makes it difficult to fix your hair because you're touching the wrong side of your head. Lync, all about the user experience, it's a mirror. So you see straight off your camera, non-encoded mirror. It's like raise your hand, no delay. The way the panoramic works is, one, you wouldn't want to mirror it because it would look silly, because you might have like presentation or something you can see up on the board. And then the other thing is you're actually seeing the encoded data. So if you see your active speaker and you raise your hand, you could potentially see your hand in the panoramic raise just like that split second later. So you're actually looking at the encoded data and everyone's seeing the same panoramic signal. So let's take a look at the math for this. So the first thing is that I added this slide like right before coming out here last week, because it made me think about, you're planning for networking or planning for video. Don't forget about audio. It's not embedded. Don't assume that the video numbers include the audio, because clearly audio is part of the video. If you don't have audio in the video meeting, it's not really helpful. But these numbers are pretty low. The other thing you'll notice is they're down to the tenth. They're very specific. This stuff has been out there for a while. There's been a lot of guidance and testing and best practices and just real-world usage out of audio. The video isn't quite as mature as that, just based on the fact that everyone uses audio and not everyone uses video yet. So these numbers are really fine-tuned and very specific. So you want to make sure you add these to the total numbers. And there's the bandwidth calculator for Lync includes this type of stuff as well, as far as what codecs you're using, what type of call scenarios. Also, it's not just the media payload. Don't forget about the transmission, the communications between that. So when you send media, there's the pipe that has the media in it, and there's another pipe of, because the media can often be UDP, and it's just send the data, and I don't know if it got it or who knows. And then we have that secondary TCP connection of like, hey, yeah, I got the data. Actually, I'd like a different request. I'd like different frame rate or whatever. But that channel is additive. So for each codec that's involved, there's just another little 5 kilobit header. So audio takes 5, video takes another 5, and if you're in that scenario where I have to send an SVC and an RTV stream because of down-level clients, there's another 5. So only 15 kilobits, but when you're adding all this stuff up and you're thinking about many streams, that stuff can add up. So when we look at video, the first thing is there's a lot more resolutions available in late 2013. 2010 had just RTV. Well, there was another codec for legacy interop, but from just the RTV standpoint, 5 resolutions. There were 4 for the main camera, QSIF, SIF, VGA, and 720p. QSIF was in there, almost never used. I don't think I could ever actually get it to work. You basically just got a really low resolution SIF when you had like no bandwidth. Those are still in there. And like I mentioned, I think in the first slide, there's some additional resolutions and aspect ratios for RTV. So depending on whether you need to encode RTV or SVC, there's a whole list of choices. So it's not just one low, one medium, and one high. There's 1080p, so there's an additional high resolution. There's 4 choices in that mid-range, and then there's 6 choices in the low resolution range. The other thing is that 5th one I mentioned for RTV is panoramic. There was just one panoramic view. So even though there's new Polycom CX devices that support high definition, if you hook those up to a Lync 2010 client, it's still limited to RTV. It's still going to send that basically 144p scenario or resolution. The Lync 2013 client, coupled with the new CX devices that support 1080p, has the ability to encode 720 or 1080. So you'll see that those are a little bit more. But that panoramic number is not very high when you compare it to other ones because it's a slice, right? It's like 1080p, but it's not actually 1080p. It's 1920 wide, but it's like a 1/6 or a 5th of the bottom of the screen, just a slice. The other thing that Microsoft did is, let me go back a slide here. These numbers, we're looking at the raw audio, and then we add some IP information, and add some signaling, and then FEC, forward error correction. So if you want to plan for a network where you don't need forward error correction, which I have yet to ever find one, you could do that. But with the video, it's much more simplified. Microsoft basically rounded up some numbers and said this is maximum. Like this is all the video plus the forward error correction, meaning if you're in a really, really bad network and we're retransmitting a ton of packets and your video's still working, this is those high ends you're going to see. The bandwidth calculator I mentioned, there's a tab. Anyone's ever looked at it, there's a tab buried in the middle. It's like all red text says do not mess with unless you know what you're doing. Don't mess with it unless you know what you're doing because it's going to change all the calculations and all the tables. One of the things in there is there's a video bandwidth like average factor, and it's set to 0.8. So they're measuring 80% of maximum for your planning. And realistically, when you look at data, you are not averaging 80% of the maximum numbers. So what the bandwidth calculator is giving you a lot of overhead. One, just so you have the overhead, you don't have poor experience. And two, it's leaving room for forward error correction, which forward error correction is happening in almost every call. Down in the Polycom booth, we're demoing something that's new that we have not put FEC into it yet. So we're actually showing just the raw SVC without the forward error correction. And even in that little environment, not over the internet, just a switch with packed in a room, it's probably overheating in that little cubicle. We're seeing packet loss and sketchy video and stuff. So even in like a near perfect environment, forward error correction comes into play. I mean, packet loss is just, it's always there. And it's not necessarily packet loss, but packet delay, anything out of sequence. So forward error correction is very important. So don't assume like, oh, my network's awesome. I don't need to worry about forward error correction. These numbers have it baked in, and you use those as your yardstick. Another thing to point out, earlier I talked about the frame rates. Not all the resolutions support 30 frames. So some of the lower resolutions are limited to 15 frames. So as we get to the end and see how the resolutions that are most commonly used are in that area, it's also low frame rates too. So the actual bandwidth numbers are very quite low until people ask for higher resolution, and then they have a laundry list of resolutions they could potentially use to give that higher quality experience. But why send 720p if someone's looking at it in a 1 by 1 inch window? It's a waste of data. So we start to look at actual real numbers. So some of the stuff is pulled, these numbers are pulled from data that I'll show in more detail in the next section from Microsoft. But basically, some of the trends we're going to see here, and I've already talked about, look at the peer-to-peer session numbers, a little under 500 kilobit for a typical stream bit rate. Conferencing is nearly half of that. I mean, more like 60, 65%. Again, conferencing video requirements are lower in bandwidth. And if you look at the maximum numbers, if you go back to the last slide, you'll see that the maximums are based on the maximum bandwidth plus those 5 or 10 or 15 increments for the control protocol. The other thing to talk about is that send and receive are almost the same. Now think about the fact that if I'm requesting somebody's resolution like in the gallery, or here's the example. Everybody's looking at the same gallery. Everybody's on 1080p, the same 5-person gallery. Nobody's futzing with the display. In theory, everyone should be asking for the same resolution and sending the same. So everyone's got about the same send and receive, because I'm encoding a 240p stream and I'm receiving a bunch of 240p streams. Now this is per stream, so if I'm receiving 5 streams, the receive in total would be times 5, but the streams are about the same. If people are doing stuff like going full screen, then I might have to send 2 meg to send 720p, but I'm still looking at gallery. I didn't change. So that goes back to where I mentioned before that I cannot touch my PC. Someone else can make changes, and my bandwidth requirements just changed. Someone just said, hey, I'd like to see you in 1080p, and Lync doesn't pop up and say, hey, someone's trying to kill your computer. Lync just goes, yeah, that's fine. You're gonna see me pixelated in a large window right now because I can't do that. So again, you can't control. You can request and ask, but you can't control the foreign experience. Especially if you try to do that stuff. Lync, very important to. So we're basically retain that experience and not allow changes to water it down or make it poor. Audio being most important, so you don't want to affect audio, but you also don't want to have poor video. So I don't want the max headroom effect of high resolution and all blocky bat, 1 frame a second. I want to have smaller resolution, higher frame rate, maybe motion versus sharpness. There's all these pieces that go in there, and Lync tries to protect that experience. So if we take a look at peer-to-peer calls, actually if we look from right to left, so open up Lync, I call Dustin, I hit video, and I don't mess with the size. On a 1080p monitor, that's 240p is the default resolution. So even smaller monitors, that resolution could go down to 180, but typically 240 is like that starting point. For whatever reason, I don't mess with my video, or maybe I add content, video gets pushed off to the side, and we're sharing our desktop. Very low resolution, also 15 frames a second for that resolution. So we're talking average of 100 kilobits, maximum of 500 kilobits. It's not much at all. That's lower than even our TV sessions can be. Now, as I start to resize that, based on the size of the window, Lync will hit these little trigger points where we go, okay, I've just gotten above X by Y. Now I'm going to amp up my request and ask for higher resolution because Microsoft designed it that way so you don't just start getting a big window and then get poor resolution. So with all those choices, you can stretch the window, and then all of a sudden it'll get better. And you stretch the window and it looks a little pixelated and it'll get better. So there's all these choices. In our TV, it was easy to see. It was SIF in the low window. If you popped it out and made it a little bit bigger, and it got sharper, but the resolution or the aspect ratio didn't change, that was our TV. If you grew it out even bigger and you saw it snap to 16 by 9, I'm sorry, that was VGA. Full screen, or maybe not full screen, but big enough that you see it snap widescreen, that's 720p, assuming that the other person can actually send it. So it was really easy to look at it, or at the video, and either we're comparing two 4x3s of quality or the widescreen, and you could guess. In SVC, I have no freaking clue. I'm like, I don't know what resolution this is. I'll have to go look at the monitoring database to guess, or to look it up, but that's the point. You shouldn't have to worry. It shouldn't be like a poor, a good, and a great experience. It should be a good experience across all those sizes and utilizing the bandwidth correctly. So one of the things to notice here is that these numbers, like 1080p, almost 3 meg for average, that's a lot, but I had to find some of the quad-core PC, even with Lync 2013, to send and encode 1080p. So even with those hardware offloading capabilities, you're going to see high definition in terms of 720p more often, but 1080p still takes a lot of horsepower, and it's high in bandwidth, and it doesn't come into play very often. You'll see in slides towards the end just how infrequently that actually happens. But let's take a look at the, so just under 3, about 4, 4.5. The maximum bit rate for that resolution is shown as 4 meg. You're going to see spikes above that. That could be, in fact, I remember Dustin was even having some packet loss during this call, because I went back and looked at some interesting numbers. So there could be a whole bunch of retransmissions. If we look at a multi-party call where it gets really interesting, we'll build this out slowly so it makes sense. So I do a meet now, drag Dustin in, same computers, clearly not the same day because apparently I changed my shirt, but the same networks, so the numbers are relatively the same. He may have the same amount of packet loss, maybe he doesn't on his network, who knows. But roughly 2, roughly 4 for average and total. We bring in a second person, and now what's happened is look at the bandwidth, it's almost doubled. But what we've done is we've asked for a 1080p stream of this much, and we're able to fit 2 720p streams in this window. So now we're actually asking for more because 2 720p streams total more than a single 1080p. There's just more data. So what's happening is the 1080p stream is pretty much good for my screen size, but 720 still fits on these screens, but I'm actually getting more than I'm able to show. But I don't want to drop all the way down to like 540 because maybe that's not as good. And again, this isn't scientific in terms of you always see this. I could be getting 360 from one of those for whatever reason. But if we just look at the maximum you can fit in these screens, it goes up. So it's not looking good for multi-party conferencing, right? I mean, what do you think is going to happen when I add a third? It goes way down. Because now, there's no way I can do 720p. In fact, 540 doesn't even make sense. By adding that third person, we've shrunk so much, we're asking for 360p, which is way lower. I mean, now we're dropped down into standard definition right in the middle of the resolutions. Maximum bandwidth now is half of what the average was before. So when you think about conference calls, you skip over these 2, 3 steps pretty quickly. Half the time people have their cameras turned on. You've already got 5 pictures on the screen before cameras start to turn on. So in these heavy usages, unless it's just a couple person and 2, 3 party in the call, you're going to see that taper off. We add another person, and it's going to drop even again. And again, you could do the same call, and maybe it would go up by a little bit, but the average and kind of that curve is pretty applicable to most calls. Because now some of those windows got small enough to even go to 240. And what we're seeing here is there's a mixture, because the more you have in there, the more capabilities you have for differences. So maybe one of these, I see I added Chris in that call, maybe he can only send 240 for some reason. So a couple of them are 360, that one's 240, so that's why that kind of hovered around there. But this is where that law of diminishing returns starts. I can't really get much lower in the resolutions. So I'm going to get the same resolutions from everybody. I'm not re-requesting, because I haven't gotten to the point where I want 180p because it wouldn't look good. The window's not small enough. I add content, maybe that'll happen, but right now I'm just talking video. All I'm doing is adding another stream, so that's why it jumps up by a certain amount. Maybe one of those streams went from 360 to 240, but I added another 240. So here's where we can see if I continued to go, what if Lync supported 10 or 20 or 15 simultaneous frames, like in a massive Brady Bunch scenario. it's just going to go up. We can't really get any smaller in resolution. There's one step down from 240 to 180. So also we have a lot of streams, a lot more processing. So this is kind of underscoring why 5 people in the gallery view? Why not 3? Why not 74, right? At some point, you have to pick. This is probably the ideal number to improve the experience, but not just like totally destroy your network. So these are the numbers from the monitoring, the media quality reports from the monitoring database for that exact call. A couple things, I pointed this out before. The two 720p calls, or the 720p resolutions together are more than just a single 1080p. It's just more pixels, whether we're actually utilizing that quality, it's in there. When I look at the full gallery, I see I've got 3 360p requests and a pair of 240s. One of those 360s, for whatever reason, is 15 frames. Another one of them is 30 frames. So the bandwidth differential on those is pretty high as well. So frame rate has a pretty big impact to that, not just resolution. So let's say you want to control this stuff, right? I still haven't convinced you that video is actually pretty flexible and you're still paranoid. So what can we do with that? First of all, let's take a look at what the configuration is in default by Lync. There's some default settings, and this is policy-based. So I've shown the global policy, and I also created like a large meeting policy as an example. So you don't have to make the change to everyone. You can put users and sites and define them with a policy that's unique. One of the interesting things, well, I'll get to that in the next slide. So you can control that. Here's the defaults. You've got that flexibility by policy. So let's say you're just totally paranoid. I'm just going to turn the freaking thing off. I'm just no video. In Lync before, you would in 2010 OCS, you didn't have a lot of flexibility in that, so it was just like, okay, no video for anyone, federated, local, whatever, doesn't matter. Nobody gets video. It's a lot more granular in 2013. So basically, what happens is you can do it versus peer-to-peer conferencing. So you could say, I want peer-to-peer video, I don't want conferencing. I might argue if you're going to do that, do the inverse. Peer-to-peer could use a lot more bandwidth per call than just bringing everybody in a conference call and using that way. The other thing is, we talked about RTV in Lync 2010. When those clients are connected to these environments, either directly or through federation, they have to adhere to the policies of that environment. So the RTV settings are still in there, but again, it's just very simple. It's just, set the resolution. So RTV is based on, if you define a resolution, your bandwidth is limited to that resolution. The way SVC works is there's so many resolutions it wouldn't make sense. It's just about limiting the total kilobits, and then whatever that ceiling is, it'll use the resolutions that can actually function within that. Or if you go too low, not function at all. So let's say you're like, I'm not going to shut off video, but I wasn't paying attention to the first slide Jeff went over, and I think peer-to-peer is better than gallery, so I'm going to shut gallery off. So you can do that. And again, it's not for everybody. So you can set it based on conferencing policy. And let me point out one thing here I skipped over. So even though this commandlet is get CS conferencing policy, it applies to both conference calls and peer calls. So you just got to read the documentation to know which one you're doing. And you can, it doesn't mean the setting applies to both at the same time. Just the different parameters in this command, some of them are for conferencing, some are for peer-to-peer. There's no CS peer-to-peer policy. So just the wording can be a little confusing. So you can basically say, I want to assign people to policies and either control when they create a meeting. They do a meet now or they schedule a meeting and people join their focus ID and go in their meeting. Gallery isn't allowed. So I don't care what that individual user's video policy is. I'm going to have people that when they set up meetings, no gallery view, just active speaker only. And it might be something you want to do for large meetings. Inherently, Lync, when you get a meeting to 75 people, the gallery shuts off and it doesn't come back, even if you go down below 74. It just switches. It's a permanent switch for that meeting in that instance. Switches off gallery and goes to active speaker. Because if we have meetings of 250 people, even though SVC is very efficient with all that stuff, we do have a lot of streams going to a lot of places. And think of the scenario where if there's just 6 people on a call, everybody sees each other. If we get on a call, I might be looking at you 5, and you might be looking at it, because you can just pull people off the standing row into the sitting row. And if that happens, you've got like a crazy amount of different streams going everywhere, and that can be taxing to the MCU. So Microsoft in their testing, 75 must have been the magic number to say anything above this, it might not even be applicable. Anything below that, we will retain gallery. And then the inverse is capable as far as, okay, I want to make it so that the user, when they join meetings, even if the user who created the meeting is allowed to use video, they're allowed to use gallery. They're not allowed to use gallery. So I could join a call where you guys all see gallery and you do not. versus joining a call where the person who created the call, gallery is turned off for every participant. So using both of those, you can kind of create a mixture and maybe set stuff up where executives get it and everyone doesn't, or the inverse. Or what's typically used is everybody in IT gets it and everyone else doesn't until you make sure it works. So let's say, okay, you get it. Conferencing, gallery is good. There's some built-in capabilities, so if you get in a large meeting, it's not just going to go nuts and crash the server. But I do want to set some limitations. So like I mentioned before, the limits weren't like resolution, it was a bit rate. So there's limitations on both the send and receive, so you can control those individually. The default settings are, and that's not a typo, it's 50 megabits. So there really is there's no limit. The number was just, Microsoft probably said, let's pick a number so high that we never limit any of the default scenarios, but if someone wants to limit, all they got to do is lower that integer, just pick a number. There's guidance on how low you want to change or how low you want to go on some of those. Because if you did, the one example is if you went below roughly 400 kilobits, if we go back and look at some of those numbers, that's enough, not enough to even get 10 or 180p, like the smallest resolution, like 180p at 15 frames. You just can't get it, so you won't be able to even build out a good gallery experience. So in that scenario, what you probably should do is turn off gallery. Don't cripple it by limiting the bandwidth below those numbers. So you can set different numbers for send and receive based on if you want to say, hey, I want to receive a lot because maybe I have a lot of download bandwidth. A lot of home users on asynchronous connections where you've got 50 megabits down, but you've only got a couple up. And then you want to say, I don't want them to be able to send too much. So then they're just sending one stream that everybody gets. They're not going, hey, I got plenty of bandwidth. I'm going to send stream A and stream B and temporal this. And you can kind of control that stuff and tweak that as well. And another important piece is if the panoramic is part of that story, that's 50 megabits per video source. So 50 megabits off my main camera and 50 megabits off a panoramic. In my head, I can't even come up with a scenario where that could even be possible. Like, it's just to get up to 50 megabits, that's a lot. So again, the number is basically just means the limits are off. Unless something happened with the client and went crazy and just started adding stuff, then it would stop it at one end. But I know my home network, 50 megabits would be about the upload or the download bandwidth anyway. So the last section here, I'll do a time check. You'll have plenty of time for Q&A. So this data came from Microsoft. They didn't actually give me all the data, thank God, because I don't know what I would have done with all of it. But they basically, Andrew, who was here earlier for a bit, was able to put all this stuff into, summarize some of this stuff, and we took a look at it, and there's some interesting parallels to other things I've seen. And I don't know, it kind of speaks for itself. So the first thing is that these two graphs are on the same scale, so you can compare them side by side. So peer-to-peer versus conferencing. First thing that's obvious is way, way, way more conferencing call. And this is minutes of video. And also a lot more growth. Like peer-to-peer, there was some growth and it plateaued, and then some growth and it plateaued. Conferencing call, just more and more people. What this means, and Microsoft didn't just start using Lync in conferencing, right? It means there actually more and more people are turning on the cameras. And it's also kind of a viral type thing. Like you get in and nobody has their camera started. Nobody ever wants to be the first one on camera. When we did the speaker meeting last week with all the speakers, Jamie, who was just here earlier, was talking. He had his video on. I had a question. I had my video on, and he thanked me for using video. I use it all day long, so it's not a big deal. But other people would start to use video then. Otherwise, nobody uses it. No one feels comfortable turning it on. So what we're seeing there is a growth in just people starting to use it more. What happens there is the more you use it, you see that value, and then you're not afraid to turn it, or you're like me and you shave every morning now when you work from home because you're on video calls all day long, and you're like, all right, well, I'm good to go anyway, so I'll go ahead and turn the camera on. So, you have a question?
Well, I just wanted to clarify, so that's a graph of 11 million minutes. Public, external to the LAN?
Okay, so the question is basically, for the recording, the question is what are we looking at in terms of those minutes? So the 11 million minutes used of video, that is just basically saying in November there was 11 million minutes of video, internal, external, conference calls, peer-to-peer, all of the data pulled from the monitoring database. So in November, Microsoft used 11 million minutes of cameras being turned on for all the people aggregated.
That's not Lync online. That's Lync,
kind of what I was
that's Lync internal to Microsoft.
Yeah, in fact, I know that they have people on O365. There's a hybrid scenario, so I don't know if this data is only on premises. So this may not be every Microsoft employee in the universe, but this is data straight from a company that's utilizing it and from a calendar year. Yeah. And when I look at other data from customers, it's very similar. There's two unique things to point out that I see everywhere, and I even see this in my own blog statistics. That dip in July, that's summer vacation, and where it looked like Microsoft actually went out of business there in November, that's vacation, right? That's the holidays. People are maybe, I don't know, Movember, no one wants to be on video, but just people not there, not utilizing, not working. You already see that just the tail end of that's gone back up in January. So we see there is that usage is going up, but it's conference calls, right? Here's a list of the top 10 most reported resolutions from all of that data. The gray bars are low resolution, the blue is medium, and red is high. So first of all, we don't even see 1080p on this list. Didn't even make it. It's probably the least used resolution of all the capabilities out there, I bet. It's just, you got to be in a peer-to-peer call, you got to have the video full screen, you got to have quad cores. You might as well use video conferencing equipment, or if it's Microsoft, just go to building 2 and go meet the person, right? It's just, that doesn't happen all that often. What's in there on the inverse of that is 240p is the most common by far. I mean, it's like the biggest line times 2. That's the default resolution I pointed out earlier. So this is an indication what people are doing is they're joining a call and they're not messing around with stuff. They're not like, hey, I'm going to move my video over here and go full screen. They're joining a call. The content's already there. The gallery was never large in the first place. Peer-to-peer calls, people aren't changing the size of their screen. They're leaving the video window. Or if they're doing it, they're not doing it all that often or for short calls. So they're doing it, but the majority of people are just joining the call. And this is Microsoft, right? This is people that understand how to use, it doesn't matter what department. They understand how to use these applications, and they're savvy with clicking around, playing with the buttons. Think about your normal users that it's like they're just clicking to join, like live meeting. I just click to join. Wow, I made it in the call. Whew, okay, I'm not going to touch anything. That's what they're doing. They just want to get in the call. Audio works. Hey, video's there is great. Content's working. Does everybody have it? So people are just consuming the product and not futzing about with it. So when you look at that, you can plan for those numbers. I'm not saying you plan for the bottom, but you don't have to be like, man, how are we going to plan for 1080p to however many possible quad-core workstations I have out there? It's just, it's way over planning for it. Another unique piece there is you got the little roundtable logo on the 144. Microsoft has a lot of roundtables. Almost every conference room I've been in Redmond or any technology center, you can't go in a room without a roundtable. So they use them all the time. So that's why that is the second most common resolution, because regardless of what's going on in this call, like I said before, you got 2 people, you got 5 people, full screen, whatever, there's only one resolution for panoramic for the old cameras, because they have all the old roundtables and the old CX5000s. So even if they're hooked up to Lync 2013, it's still that one low resolution. So that's why 144 is so common, because that just means panoramic was being used. So with newer, can we hold that to the end? Okay, thanks. With the newer equipment, the newer CX devices and higher resolutions, you'll start to see 2 or 3 of those show up, and it'll be paired. But again, that's applicable to customers that have these devices. But the top 5 right there, the top 4 are low resolution. It's the 5th one that you actually get into a medium resolution. So that's maybe conference calls of 2 or 3 people, or peer-to-peer calls that someone increases the window size a little bit, or a lot of tablet calls, even though my Surface is 1080p, so that doesn't necessarily mean because I'm using my Surface it's low resolution. But again, that general trend of just using what shows up on the screen. So the numbers there show roughly 90% of all video minutes in all the conference calls Microsoft did were low resolution. It's 1, 2, 3, 400 kilobits max. Those low averages. Again, the low resolutions are 15 frames, low frame rate. So not scary numbers at all. Almost, at least from my background, almost a little depressing. I'm like, man, I wish people would, use the high resolution a little bit more. But it'll come with that. As monitors get larger in resolution, not size, the capability to show these higher resolutions will be there. But for right now, and the key here is this is people actually using it, right? What about all the people that didn't turn the camera on? So this is a comparison to what we had a little bit before. Again, pulled from the real data. So send and receive aggregate for an average call, peer-to-peer conference calls, 800 kilobits for the average. For peer-to-peer, again, higher resolutions typically. There's one person on the screen. You have more pixels to light up. The conferencing, just a little bit over half a meg. We look at 2010. I join an AVMCU conference call or OCS. My video, whatever screen size, it doesn't matter. It's not getting any higher than VGA. That's 600 kilobit to 800 kilobit maximum for 600 normal, 800 with forward error correction, all that stuff. We're at those basically the same numbers, just a little under 600 kilobit. So we've got a better video experience, multiple people, and at really no bandwidth cost when we compare all those numbers side by side to what OCS and Lync have been doing for ages. So if you're already utilizing video in 2010, don't think that when we do 2013, the gallery view is going to make a big impact. I mean, actually, it could go down. It could go up and then go down, which I'll talk about in a second. So to summarize this stuff, video, like I got to turn the camera on. I already mentioned before, if you don't turn the camera on, then you can plan for 0 kilobits of video bandwidth. That'd be real easy. Go to lunch early, right? So who's using video, or how do you get video adoption? One big one is age, and you just without overgeneralizing, typically the younger the person is, the more they're inclined to use it. That millennial workforce, I mean, you look at Skype and FaceTime and all that stuff. When they get into the workforce, they're going to expect that capability is there, and if it is, they're going to use it. If they're not, they're going to be like, well, I'm not going to work at this company. They're ancient, right? Like, this is how they operate. People on the other side of that scale might be like, I don't understand video. I don't get the value. I go through a lot of razor blades, right? Like, I don't want to do video every day. I just want to sit home, do my conference call in my PJs, and maybe pay attention, maybe not. So there's value to video. It can be perceived. It's clearly I have my impression of it is based on what I use. I'm a little bit spoiled. I get a high definition experience with everything I do, so I see the value and add it. But if it's not a good experience, then maybe that's not there. So I mentioned earlier ubiquity. Cameras everywhere, high definition cameras everywhere, higher processing in tablets, the ability to use it. The more people use it, the more people use it, and the more people will continue to use it. And it just kind of grows on itself. But what it doesn't do is just spiral out of control. There's a definite bell curve to adoption. One of the things is you roll the product out, people start doing video, network guys looking at it going, oh boy, and then it gets to this point where he's like, I'm just going to turn it off. You got to ride that wave out a little bit or lower those numbers to control that wave, because people are going to start using video, and then they're going to figure out what that value is to them, and then they're going to decide, okay, when I do my weekly conference call with my team, video is good for that, but when I call Brennan, I don't need to see him on video all the time. We talk all the time. A peer-to-peer call, I don't need to enable video. So it's also like whether or not you use it. So use it for everything. It's neat, it's new, it's cool. And then you start to use it where you actually need to use it. So you ride that bell curve out, and then you see that's where that stuff goes. The corporate culture, that's all part of that, right? So whether video is or isn't used, or whether you want it to be used, again, age and those components go into that. And then I mentioned experience. If you have a poor experience, you're less inclined to want to use video. If you have a good experience, you get the value, and you're more inclined to use it. And then it kind of grows there from a social aspect. So you got to think about all these things. You're not just going, I have X computers and Y bandwidth and these versions of clients. Try to get a feel for your own environments or your customers' environments and decide, just how popular is it going to be, or are we going to have to force people? I've deployed Lync for customers in the past, and I go to their computer, I'm like, hey, or when I first did OCS, I'm like, hey, are you logged in? And they're like, to what? And there's a little red or green circle on the taskbar. Clients sit there running all the time, they don't even use it. Clearly, the Lync culture is not like that. People are using IM&P and the conferencing components. Videos in your face more with Lync 2013. You accidentally hover over the video button, you get your preview. A lot of that stuff is what drove that usage within Microsoft. When I used to join Microsoft calls years ago, no, they wouldn't turn their video on, even some of the Lync team. But in the last year, it's just the product is just driving that internally and for everyone else. So there's clearly an uptick in that usage. So if you're going to utilize it and not limit it, you want to make sure that that stuff's available and planned for. And then the last piece I want to talk to is just the importance of video, right? I mean, audio is paramount. If audio isn't working, the conference call is a bust anyway. Who cares? Video without audio is useless. Content is king. You got audio, everyone's connected, you can hear each other, you get everyone to mute so you don't hear the dogs barking or the people on the train that aren't actually talking anyway. You get that done. you get to content, because that's what the meeting's about. We're sharing content. And then, is there room for video? Do we have the bandwidth? Do we have the screen space? If you're on the train, you're not using video. I mean, is there room for that modality? Does it make sense? Okay, we add it. And like I mentioned, people have a love-hate relationship with video, and for all those kind of pieces in the slide before, the adoption can kind of unfold from there. So just kind of be ready for that. So if anyone has any questions, go ahead and come up onto the mic so we can get it on the recording.
I have one question. Where does call admission control come into play with these new video?
What was that?
Where does call admission control come into this?
Oh, you know what? There was a slide. I skipped over that. So one of the things then in the... let me just go back to it. So, yeah, here, one of the things that I got from the summary from Microsoft is they're not limiting it. They still have those 50 kilobit magic numbers that are way up in the cloud, and they're not utilizing call admission control for that. And you don't necessarily limit video bandwidth for CAC. That's not what CAC is for, right? I mean, it's part of that, but they're not limiting bandwidth at all in their environment, because what they've seen is they don't have the need, because the usage of it is not outpacing any of their network capabilities. Is it possible? Oh, yeah, it's always possible. Everybody gets on a call, and they all turn video on, and you have all these different calls going simultaneously. You could do that, so you certainly want to watch for it. But you can look at the monitoring and reporting databases and look at that information and find out just what's actually happening on a day-to-day basis and decide if you're comfortable leaving where it is or using limitations to ride out that bell curve and then start to open things up after people have adapted and you figure out what the video usage trends are.
But a particular bandwidth setting in CAC could eliminate actually...
Oh, yeah. So definitely... So these are additive. So if you've got the limitations on the total bandwidth, but then there's limitations on the site links for CAC that's lower, then it's just going to be like, well, that's all I can do. So this goes back to where I said, you request a high resolution from me, and I look at what I have, that figures into it. So even if I have a ton of processing and my local bandwidth is high, but CAC policy says you can only use 500 kilobits per stream, you're not going to get 1080p or high def. I'm going to send you 360 or whatever. So it definitely is applicable. Any other questions?
On desktop share, RDP traffic can also be fairly heavy. We've done some analytics and modeling of how that impacts network performance recently. I don't know if you have any comments around RDP traffic in addition to video, audio, and managing expectations.
Yeah. I haven't done any research. I don't have any slides or anything other than my own, my own testing and what I've seen. And yeah, it can be very bursty. And especially if you're doing things, like if you're showing a PowerPoint through President and you're not doing like the WAC update and all that sort of upload, you hit the right arrow, meg and a half, and then it drops off. If you're doing things where there's motion or you're dragging windows around or any stuff like that, it can get very bursty. So just like I had the slide, don't forget about audio. I didn't want to get too out of the video portion for the session, but yeah, it's all part of it. I mean, you could even say, hey, we should worry about the IM traffic, but I'm pretty sure those SIP messages are small. So you want to make sure everything you see on that screen, that it's all additive.
How about QoS markings? Do you see a lot of companies strict about not running video unless you have QoS classification and marking in place?
Yeah, basically what I see is a mix of everything. Some people like no QoS, we don't use it. Some people like, if it doesn't do QoS, I'm not going to run it. When you start to talk about Lync, you're talking about audio and video. The Lync phone editions have QoS enabled by default, but the Lync Windows clients do not. Video you can enable. You can mark all the media for QoS. When you talk about like Macintosh clients, they don't support the same marking as Windows clients. So if you have Macs involved, then you only have the one choice. So there's a lot of different scenarios in there. I don't see a general it's pretty much two camps. I just let it do its thing, and I'm not tagging it because a lot of my stuff is over the internet anyway. I have a distributed workforce, and everybody's at home. It doesn't matter if I tag it because it's gone once it hits the edge. And you have other companies that are like, we're not doing anything until we spent 15 years of meetings doing QoS, and then maybe we'll turn it on. So
how much percent of those?
That's a wide, small percentage. It's a very small example, but it's about planning it and understanding it, and then really it's how friendly is the network guy when you're in those meetings? You know, are they worried about it, or are they like, no, I saw some presentations, I'm not too concerned. Yeah, there's no one size fits all in that scenario.
So for like planning video, generally they say 1 or 2% concurrency is what you should plan for. I'm just curious if Microsoft in their usage information provided you with any of the concurrency.
Oh, you know what?
I didn't see it on there. I just didn't know if it didn't make the presentation or not.
Yeah, so the one thing I do have on that, again, on this slide, is I talked about at the beginning all the potential streams. So when you look at all that data, not even 2 streams are the average. An average of 1.5 streams, or less than 1.5 for conferencing, and these streams could be multiple streams for SVC and RTV for federated B2B with 2010, or scenarios where there's so many requesters of different resolutions and frame rates that there's multiple streams. But typically, it's 1 stream, and then an RTV here. 40% of the time there's an RTV added or something like that. So it's low numbers.
Right. I think I was getting more towards like a per user type of concurrency. So like at any given time, maybe there's 1,000 people using video.
Yeah. No, I don't have that information. So when you look at the 11 million minutes of video, how many billion minutes of audio or whatever, right? Like it's still a small slice, but based on the meetings I've been in with Microsoft, it's more common. So you kind of take that as, it's certainly a subset, but I don't have any numbers or percentages.
Just curious. Thank you.
Hey, Jim, I'm sorry, can you go back to the LRS slide?
Sure. This one?
The Lync room system, room system slide.
Yeah, well, I didn't have anything on Lync Room System specifically. Oh, okay, yeah. Now, this was just about the Lync Room System experience in terms of the fact that you can go video in 2 screens and utilize more. If you want to see Lync Room System, there's like 6 of them. It's like 6 of them down in the Expo Center, too. Oh, you know what? So, yeah, so basically LRS is Lync. The bandwidth is no different because it doesn't matter how big the screens are.
Yeah, but it's 1080p, and nothing else. As your own statistics are showing, there's not 1080p going on anywhere else. But with Lync Room System, there is 1080p going on. So that was more the concern.
Yeah, but I can do 1080p on my Lync client home hooked up to a 22-inch monitor.
You can.
Yeah.
I can't. Most people don't have quad processor and the
Agreed. Yeah. So yeah, Lync Room System isn't unique. It's just the fact that it's up at the top of the table. So
yeah.
If I take a quad-core PC and hook it up to two monitors, it's the same bandwidth. So your Lync Room System fits in that parameter.
Yeah, I hear what you're saying. Just consider it's just a 1080p, basically.
Yeah.
Okay.
Yep. But again, if you're in a gallery call, you're not getting 1080p 5 times because now you're shrunk down. So it's
right, exactly.
middle to middle resolutions. Yep.
Okay, thanks.
So just as a follow-up to that, can you comment on the hardware you use to get you mentioned that you do HD video all day. Is that any different with the Lync clients, or is it Polycom special?
Well, that's me with a $10,000 video system at home that I don't have to pay for, right? So that's why I make sure I shave. Yeah. But from a Lync standpoint, with my dual-core workstation with Lync 2010 or with Lync 2013, I can encode 720p. Mm-hmm. If I have like a quad-core PC, then I can encode 1080p, but only if it's being requested. And most times people aren't going full screen with my video on a whole screen. So most of my Lync calls I do about middle resolution. I'll bring them over to my side, the one screen, and drag it out. A lot of times my second screen's not even lit up anyway. Okay. So it fluctuates. And honestly, as a user, I'll go full screen and I'll hear the fan crank up on my laptop, and because I have like other things running, and I'll just resize it smaller to make it go away. So I kind of, pay attention to the processing usage.
Yeah. All right. Thank you.
So we have 5 minutes left, but there's not any other questions. We can go ahead and wrap up. And if you guys just want to, ask one-on-one questions or whatever you want to do. Thanks.